Hi, my name is Patrice Witschen, and I am a third year PhD candidate within the CMB program in Dr. Kaylee Schwartz-Fager's lab. And my thesis project is titled Hyaluronin Processing and Function in the Progression of Breast Cancer. So before we get started, I want to introduce hyaluronin or hyaluronic acid, which is something you might be more familiar with. So hyaluronin is this high molecular weight molecule that's present everywhere in your body. You can find it in your joint capsule fluid or your skin, and its predominant role is to maintain hydration of some of these tissues. And therefore, because it's really present everywhere under normal physiologic conditions, HA is thought to be tumor suppressive. However, if this high molecular weight molecule gets exposed to some sort of cellular or organismal stress, it can get cleaved into these low molecular weight fragments, which are thought to be tumor promoting. And we know a lot about HA within the context of cancer from this guy here, the naked mole rat. So a lot of work has been done within this species because the naked mole rat actually lives to be a very long uh, lives to have a very long life with an average lifespan of 30 years, which is ridiculously long for a rodent of that size. And in fact, Science magazine termed them beauty queens because they have this ability to resist cancer and live a very long time. And they have been shown to actually synthesize a high molecular weight molecule of hyaluronin, and they don't fragment HA into these low molecular weight fragments. And this has been shown to lead to their resistance or inability to get cancer. So in the context of breast cancer, which is what I study, we're really focused on and trying to understand how tumor cells interact with their environment to ultimately support disease progression. And so pictured here in these blue squiggly lines, you can see that hyaluronin, which is a component of the extracellular matrix, really can surround actually the bulk of the tumor as well as individual tumor cells themselves. And if we look at a murine mammary tumor by immunofluorescence, you can see that synthesis or HA is deposited throughout this tumor. However, these images don't allow us to look at the fragmentation status of hyaluronin. And so ultimately, the goal of my thesis is to really zoom in um, to within these breast cancer, within these tumor tissues, and ultimately delineate which cells are synthesizing HA, is there HA fragmentation occurring, and ultimately how is this HA synthesis and fragmentation promoting breast cancer progression potentially through the expression of inflammatory mediators. And ultimately, our goal is to improve breast cancer therapy for breast cancer patients. Thank you.